What I'm going to do is I'm going to give you guys an example of, if you guys remember, here's the parent graph, right? So the basic thing, John, that you guys can do, what I would recommend is just write in what the graph looks like. You guys should all know whenever we're looking at any kind of function, you should know what we call the parent graph, what that looks like. And that's going to be kind of like those little dashed lines. However, what we've done is we now have a graph, a reciprocal function, that has transformations. So what are those transformations? Well, we see that our a is negative. So we're going to reflect the x-axis. So just like I showed over here, the reflection of the x-axis is the red graph. So rather than our graph looking like this, we're going to have to reflect them to the other quadrants. Does that make sense? Yeah. OK? So our graph is going to look like the red ones. Now, we need to look at the transformations. And again, this goes back to knowing the rules and writing them down. So when you look at this, if you identify, you say h is equal to 1. That means we're going to shift 1 unit left. So we're taking this graph, the red graph, and we're shifting it 1 unit to the left. So the best way to be able to graph this is to shift the asymptotes first. So the asymptote is originally at x equals 0. Now it's going to be at x equals -1. OK? And I'm going to erase this black one because we don't really need that. It's the original parent graph. So now I'm taking this red graph. I'm shifting it 1 unit to the left. And then it says h is equal to k is equal to -4, which is going to shift 4 units down. So I'm going to go down 4 units. 1, 2, 3, 4. So what I want you guys to see is originally I graphed the red ones just with the reflection without shifting. Now what I'm going to do is I'm going to take this red graph and shift it so it matches the vertical asymptote, and then shift it down so it matches the horizontal asymptote. And when I do that, I obtain a graph that looks something like this. So it's this red graph shifted 1 unit to the left and shifted 4 units down. And the reason why we did that is because our values of h and k. Yes? Absolutely. So when we're looking at the domain and range, the best thing to think about with domain and range, remember domain, guys, is the set of all x values. So if you look at this graph, this red graph is going to continue to go to infinity, right? But then as I'm coming into the graph, it starts to sharply go up. Remember, it never crosses this asymptote. It only approaches it. So what is the value of that asymptote? What is that asymptote? X equals -1. Why? Because this is 0, 0. If I go over 1 to the left, that's an x equals -1. I don't get it. This is the vertical line, x equals 0. You have a number line. 0, 1, 2, 3, -1, -2, -3, right? That's what we call the x-axis. Yes?
I get it.
This is called the y-axis. Another number line, 1, 2, 3, -1, -2, -3. So if we have a vertical line right here, what value is that? That is when x equals -1. So what I want to explain to you, so with the domain, what I want you guys to see is this graph, except for -1, so it goes to -infinity. As it's going to the right, it sharply increases up to this asymptote. It never touches -1. Then if we go over to the other side of -1, it approaches it from the other side, but then all the way goes to infinity. So the domain is all real numbers, except x cannot equal -1. Because what's at -1? The asymptote, where the graph approaches.